So dear students, let's recollect what we had learnt previously, that an arithmetic progression can be defined as a list of numbers which are got by where the common difference is constant throughout the list, correct? So, and we represented the first term as A, the common difference as D. And how did we calculate the common difference? The common difference is nothing but the succeeding term minus the previous term. And if the common difference remained constant throughout the progression, then we said it is called as an arithmetic progression. And we also calculated the formula. We derived the formula to find the last term of the arithmetic progression, which was nothing but an is equal to a plus n minus 1 into d. So, with the help of this formula, you can calculate the value of any term for a particular progression, provided you know the value of a, that is the first term, and the common difference, correct? And then we said that the general form of an arithmetic progression is given by the form of a plus d, a plus 2d, a plus 3d, so on and so forth. We also studied the concept of finite and infinite progressions. Now let us go to one other important concept in arithmetic progression, which is called as the sum up till the nth term. Okay. So now when we come to the concept of sum up to the nth term, generally the arithmetic sequence is generally written by a comma between the two terms, correct? That is how we wrote the arithmetic sequence when we did problems or when worked examples were done. But now when the comma is removed and a plus sign is introduced between the two terms, that is between the value of the two terms, then such a sequence turns into an arithmetic series. Now let us come to a derivation to find the sum up to the nth terms. So the concept now is to find the sum of n terms. Since we are talking in terms of sum, it is represented as s, and we are talking in terms of n terms, so it is suffixed with n. Okay. So now we need to go back and recollect how the arithmetic progression is being written. Say for example, the arithmetic progression is generally written as a plus d, a plus 2d, a plus 3d. But since we are talking in terms of the series, what do we need to do? We need to introduce a plus sign between the two terms. So then it turns to be a plus d plus a plus 2d plus so on and so forth, finally plus the last term can be got by writing a plus n minus 1 into d, correct? So now we need to find the value of s. So what do? We write the same terms again in the reverse order. So when we write these terms in the reverse order, how does it look? It will become s is equal to a plus n minus 1 into d, this is the last term, plus the previous to the last term. So this is a plus n minus 2 into d plus again a plus n minus 3 into d, so on, and it reduces to a plus d plus a. Now what do? We need to add both these expressions. So on adding both these expressions, s plus s on the left hand side will give us 2s, and rearranging and adding we will get a plus a to a. So this is appearing 2 times, this is appearing 2 times, this again will appear 2 times. So finally you will get this as 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus 2a plus n minus 1 into d, that is how many ever terms that you are writing. So that is nothing but this is going to appear n times. So if I were to write it again, so Sn is nothing but n times of 2a plus n minus 1 into d. Now since I need only s can be got by writing n by 2 into 2a plus n minus 1 into d. So dear students, this is an extremely important formula that we will be using to solve quite a few number of problems. Now one more concept needs to be understood here. If you observe what is the value of an is got by writing it as a plus n minus 1 into d. Am I correct? Now if you observe, this can also be written as n by 2 into 2a can be split as a plus n minus 1 into d. All I have done here is I have split 2a as a plus a. Now a plus n minus 1 into d, this is nothing but your an, correct? So one more formula can be rewritten as n by 2 into a plus an, or generally we write an, since an corresponds to the last term, it can also be represented as L. So the formula can also be rewritten as, this is another important formula, since an is equal to L, S can be written as n by 2 into a plus L. So clearly we know that, or you can write this as L. So clearly L is equal to a plus n minus 1 into d. Now when do we have to use this formula? When do we have to use the previous formula? It is very simple. When the values of a, d and the number of terms, that is n, is known to us, then we can use the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. Now when the last term value is known to us, then we can use the formula Sn is equal to n by 2 into a plus L, correct, where L takes the value of the last term. One more important concept that you need to understand here is that when we are talking in terms of a is nothing but the first term. So the value of the first term can either be a positive value or negative value, correct? So depending upon the value of the terms in an arithmetic progression, d can either be a positive value, negative value or a zero value. But very clearly n, which tells you the number of terms which are present in an arithmetic progression, can never be a negative value. It always has to be a positive natural number, correct? Because there is no point in telling that there are minus 17 number of students in our school, or there are about minus 2.5 number of subjects that we need to study in our school. So n always has to be a positive natural number, and it can never take decimal fractions. It can never be a decimal or a fraction. Make a note of this so we can proceed to the next concept. Now let's summarize the chapter. So we first wrote the definition of an arithmetic progression. So how did we define? An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number, or in other words you can say this as a common difference D to the preceding term except the first term. Except the first term. Correct? So now the key words in this particular definition was a term, then D, which is called as the common difference, and of course the first term, which is represented by A. Now if you can recollect, how did we write the term? Terms are nothing but A1, A2, A3, so on and so forth till the last term, which is given by AN. The next definition we studied was the general form of an AP is given by A plus D, A plus 2D, so on and so forth. Next concept we studied was the concept of finite AP and infinite AP. So depending on whether the last term is known to us or not, the AP can be classified as finite or infinite. That is, if the last term is known, then it is called as a finite AP. If the last value is not known, it is called as an infinite AP. The next concept we studied was how to calculate the common difference. Common difference D is got by subtracting the succeeding term with the previous term. Please remember, this is a very important concept that you need to remember throughout arithmetic progression. That is, it is always the difference between the succeeding term and the previous term. And this common difference has to remain constant throughout the arithmetic progression. And always D can either be a positive, negative or a zero value. Whereas N always is a positive natural number. Again A, that is the first term, can either be a positive or a negative value. The next concept that we studied was to find the nth term. So how do you find the nth term? An is equal to A plus n minus 1 into D. So this is an extremely important formula to calculate the nth term or the value of a term which is given for a particular arithmetic series. And finally, we learnt to calculate the sum of n terms, which is nothing but the series Sn is equal to n by 2 into 2a plus n minus 1 into d, or if the last term is known, then it is n by 2 into a plus l. So dear students, with the summary of arithmetic progression, we have come to the end of this chapter. Please practice the problems once again to get a better knowledge of the chapter. Thank you. So now let's start by working out the first word example on arithmetic progression. For the AP, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, write the first term A and the common difference D. It's a very simple problem. Since the AP is already given as 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. So as you observe here, since A is called as the first term, we can clearly write the first term A is given by 3 by 2. Now since they have already mentioned that it is in the AP, you don't need to confirm whether the given sequence is in AP. We can find the common difference by subtracting T2 minus T1 or T3 minus T2 or T4 minus T3. So to find the common difference, D, which is simply given by the second term minus the first term. So what is the second term here? Half minus 3 by 2. Since the denominators are the same, we don't need to do the LCM. Directly we can subtract, which is given by minus 2 by 2, which is equal to minus 1. So this completes the first work example. Now students, now let's move to the second worked example. The problem reads, which of the following list of numbers forms an AP? If they form an AP, write the next two terms. See dear students, we have two problems here. The first is they want us to check whether the following sequence is in AP. So as I explained earlier, how do you check whether the sequence is in AP? The common difference between any two terms in the sequence has to remain constant. If they are constant, then definitely that sequence comes under AP. So once it is in AP, it is very easy for us to find the next two terms. So look at the first problem here. It reads 4, 10, 16, 22. So now first let us list the data which is given to us. So according to the sequence which is given, the data says A value is equal to 4. Correct? What is A? A is the first term. Now how do we determine whether the given sequence is in AP? We need to check whether the common difference between the two consecutive terms is constant. So let us begin by checking whether the common difference is constant. Suppose we take A1, A2, A3 and A4. So now how is D given? D is given by A2 minus A1. So in the first step it is 10 minus 4, which is equal to 6. So here we cannot stop and say that the particular sequence is in AP, because we need to further check whether the common difference is constant throughout. So now let us call this as D1. Now D2 can be got by A3 minus A2, which is A3, 16 minus 10, which is equal to 6. So now dear students, we have observed that the common difference is constant. So now let us proceed to the second part of the sum, which asks us to find the next two terms. So now we have found, they have given the sequence till A4. So they are asking us to find A5. How do you find A5? A5 is found by the previous term plus the common difference. So which is the previous term here? 22 plus 6. So next term is going to be 28. Now A6 can be found by writing A5 plus the common difference. So 28 plus 6, which is equal to 34. So now the next two terms of the given AP are 28 and 34. So the next part of the question, it says 1, minus 1, minus 3 and minus 5. As usual, let us find the first term. The first term is given by A is equal to 1. I don't think it would be a problem for you to recognize the first term, simply because whichever term is given in the sequence is taken as the first term. Now let us check whether the sequence is in AP. To check whether the sequence is in AP, again we need to find the common difference. So how do we find the common difference? D1 is equal to, like again, let us take this as A1, A2, A3, A4, and so next D1 will give you A2 minus A1. So dear students, be very careful whenever there is a negative sign given in the particular sequence. So this is minus 1 of minus 1, which is equal to minus 2. So the next part of it is D2. D2 is given by A3 minus A2, which is A3 now, minus 3 of minus 1. So this is minus 3 of plus 1, which is equal to minus 2. Again, the common difference seems to be constant. So now let us find the next two terms of this particular sequence. So the next two term, that is A5, is equal to, you have A4 plus D. Now which is your A4? A4 is minus 5, common difference is minus 2, so which is equal to minus 7. Likewise, the next term A6. A6 is given by A5 plus D. So here, which is your A5? Minus 7 plus of minus 2. So it is minus 7 minus 2, which is equal to minus 9.